Welcome back, Logan. Let's jump into this next math from your couch topic. We're just going to extend the second video of simplifying rational expressions. So on this one here, what I do want to do is focus in on polynomials. So the last one we looked at, we had monomials, and now we're going to look at polynomials. The idea is still the same. You're going to want to factor this stuff as much as possible. So you're going to factor these polynomials down as much as you can. All right, so let's take a look at our first example. So number one, we've got x to the power of 2. We've got x to the power of 2 minus 5x minus 14. So we're going to take a look at that. X to the power of 2 minus 5x minus 14 over x to the power of 2. Let's make that look like a 14, sorry. X to the power of 2 minus x minus 6. So the first thing you're going to want to do is you're going to want to factor these things. Now, the way you factor it, you're going to break down. You're going to try to figure out what multiplies to give you the x squared. So I'm going to go x times x gives us x squared. So I'm going to put an x there and then an x there. The next thing is what can give us 14. So I'm going to write that down over here. There are two options that can give us 14. We can either do 14 times 1 or we can do 7 times 2. Those are the two options that we have. The next thing is we notice that it's a minus sign right there. So we're going to subtract these numbers. And when you subtract 14 and 1, you get 13. And when you subtract 7 and 2, you get 5. And all this does is it helps us figure out which one we should use when it comes to the 5x. So we notice that there's a 5x, so we're not going to use 14 and 1. We're going to use 7 and 2. Now, to get a negative 5x, it would need to be a negative 7 and a positive 2. What you'll also notice is when you multiply these, it gives you negative 14. So this is the correct factorization. So we're going to go x minus 7 and x plus 2. X minus 7 and x plus 2 over. And then we're going to do the same exact thing for x squared minus x minus 6. So we're going to break it down to two binomials. So we have enough space for binomials. X squared is x times x. So we have x times x. And then now we need to break down 6. So we have two options, 6 and 1. And then we also have 3 and 2. There are no other options for 6. And then when we looked at it, it's a minus sign. So we're going to subtract. 6 minus 1 is 5. And 3 minus 2 is 1. You'll notice that the middle is a negative 1 right there, negative 1. So we actually want this 1 right here. But to get negative 1, we would need negative 3 and positive 2. And that would result in a negative 1, kind of like the negative 7 and the negative 2 results in the negative 5. So that's our factorization. So we're going to go x minus 3 and x plus 2. And right away, you'll notice that our binomials, we have one binomial on the top that matches our other binomial on the bottom. So we're going to go ahead and cancel those guys out. And our simplified rational expression is x minus 7 over x minus 3. Now, we can't cancel out the x's because those are not factors. We can't cancel with the 7 and the 3. Well, that would never, ever happen. But the x's can't cancel because the x's are not factors. The entire binomial is the factor. So you can either write your answer as x minus 7, or you can write it as you can write your answer as x minus 7 over x minus 3 in parentheses, or you can write them without parentheses. It's your choice. All right, so let's take a look at our second example. Problem number 2. We have x plus 5. So for number 2, we have x plus 5 over x to the power of 2 minus 25. Now, x plus 5 unfortunately does not, or fortunately, x plus 5 doesn't factor, right? So that's it. It's the factored form of that. So x plus 5 is factored, so we're just going to write x plus 5. Notice I like to write parentheses around anything that's already factored, like it's kind of done being factored. Now, x squared minus 25, that's one of the special ones. And the reason it's special is because it only has two terms, yet it does factor to two binomials. X times x is x squared, and then 25, there's two options, 25 and 1, and 5 and 5. The thing is there's no middle, which means the middle is 0. The only way to get 0 is if these two guys, one was positive and one was negative. So we're going to go x plus 5 and x minus 5. And right away, you can see that you have two binomials that are exactly the same, so they are going to cancel. So those binomial factors are the same. Now, remember, when it cancels completely on the top, that means that there's a 1 up there, so we now have a 1 at the top of our fraction, and the denominator is just the x minus 5. Now, you can either write your answer with parentheses or without. It's your choice, but this is our answer for number 2. That's how that one's going to simplify. Moving on to number 3. So our third and final example, we have x to the power of 2 minus 36 over x minus 6. And we're going to go ahead and factor the top factors to x times x for the x squared, the front of it, And then the 36, we have two options. Actually, we have a lot of options for this one. We have 36 and 1. We have 12. Oh, let's go back. Skipped one. 36, 1. 18 and 2. 12 and 3. 9 and 4. And 6 times 6. So those are all the factorizations for 36 right there. And then you'll notice that it's a minus. So we're going to subtract all of these. 36 minus 1 is 35. 18 minus 2 is 16. 12 minus 3 is 9. 9 minus 4 is 5. And 6 minus 6 is nothing, 0. But you'll notice that there's no number in the middle, right? So the idea is, since there's no number in the middle, what we're going to do is we need it to cancel out to 0, which means this is our only possible answer, 6 minus 6. So it's going to be positive 6 for the front 6, and then minus 6 for the second 6, the back 6, over, and then this binomial can't factor, so I'm just going to write x minus 6. And you'll notice that we have two binomials, one on the top and one on the bottom. They're exactly the same. So we have x plus 6 on the top, and on the bottom, there's nothing there, so we're going to put a 1. Now, unlike fractions where there's a 1 on the top, 1s on the bottom don't need to be there. When you divide anything by 1, it equals itself. So you do have two options. You can write it as x plus 6 over 1, or you can write it as x plus 6. Most people would agree that this one is the simplified version. It looks much simpler than this one. This only works, just a reminder, this only works when the 1 is in the denominator. All right, take a look at the example problems. If you have any questions, hit me up on Google Classroom or email, and I'll talk to you guys.